So let's take a look at some ISA 1 problems. So the first problem here is with the PC register. Can you use the PC register like a regular register? Can you use it for reading and writing and math? Well, the answer here is somewhat. So you can do things with it. You can read and write it, and think about how, but you can't really use it for math. So if we look into this in detail, we do write it whenever we have a jump or branch, and we can access it directly if we store to it with a JR, or indirectly if we use a JAL. So by using JR, we can go ahead and write to it, and if we want to read it, we can use a JAL, which will allow us to pull the information out of it. But it's really hard to use it in general. So we can somewhat use it, but it's not a regular register. So another question about the register file. How many memory locations do we need to fill the register file? Well, it's 124 is the answer here, and let's think about why that is. There are two parts to this. So the register file has 31 words. Remember, R0 is always 0, so we can't fill that up. But each word in the register file is 4 bytes, and the memory is byte addressed. So when we say memory locations here, each location in the memory is 1 byte. So we need 31 words, or 124 memory locations. That is 124 bytes to fill up the register file. Let's take a look at branch labels. So how much space do we need for a branch label, such as skip or else, when we compile the code down to the binary for the processor? Well, the answer here is none. These are just labels. What happens is when you go ahead and you compile the code, when it's assembled from assembly into bits, the assembler converts them to an offset. So for example, look, imagine we had a label skip. If we had a label skip that went 4 instructions ahead, then the assembler will calculate it was 4 instructions ahead and just in the branch put in a destination address that's 4 instructions ahead. So the skip label itself will never actually show up in the instructions in the binary code.